All right. Remember that once we prove that two triangles are congruent, then any of the corresponding parts have to be congruent by the definition of congruent triangles. Right? If your hands are congruent, then your thumbs have got to be the same size. Otherwise, your hands aren't congruent to each other. Okay? So here, we're just matching up corresponding parts. If triangle FUN is congruent to triangle TIM, then FN, which is the first letter and the last letter, has to be congruent to what segment? What's the first letter and the last letter in the other one? TM. And what does angle U match up with in the second triangle? Angle I. And segment MI, well, now we're going from the second triangle back to the first one. MI matches up with NU. So what's going to happen is we're going to have proofs where instead of just proving the triangle's congruent, we're going to prove the triangle's congruent and then say, okay, then that means any of the corresponding parts that I want to know are congruent to each other as well. So let's take a look at this proof. We're given that SN is parallel to TU, so I'll mark that with the triangles. SN and UT are also congruent to one another. So how do I know that is true? Because it was given. If I've got parallel lines, I should have some angles that are congruent. Specifically, these two alternate interior angles. Angle SNT is congruent to angle UTN. That's because of the alternate interior angles theorem. It gives you a hint on this one. Segment NT is congruent to what? Well, it's the same in both triangles. Segment NT is congruent to segment NT. Who can tell me what that's called when we say a segment's congruent to itself? Someone said it, just not very loud. What was it? Yeah, it's a reflexive property. Then triangle SNT is congruent to, it's got to be another triangle. S doesn't have any markings on it at all. That matches up with angle U on this one. N has one mark. That matches up with T in the other triangle. And then the other vertex is N. If we look at just one triangle, we've got two sides and an angle. I always look at what we have more of first. We've got two sides and an angle, and the angle is in between those two sides. So that's side, angle, side. Once we know the triangles are congruent, then we can go on to the next step, which is proving these two angles are congruent by the definition of congruent triangles. So sometimes we're just going to ask you to prove triangles congruent, and you'll stop here at step 4. Sometimes we'll ask you to go beyond that, and you'll go to prove the corresponding parts congruent. Got to pay attention. Some people start going, oh, it always ends with definition of congruent triangles. Nope, not always. All right. So let's start looking at how you're going to approach these when you have to do them on your own. And as with most things in life, you don't get better at them until you try them. So we'll start with the given. So it tells me that LG is parallel to FS and that LG is congruent to FS. So I know that L is the midpoint of segment AS. If L is the midpoint of this segment, oh, let's just randomly call on people, because otherwise I get people who just sit around waiting until someone answers. Let's see. Pick a random number. From 1 to 20. 8, Vasari. So if L is the midpoint of AF, what else do we know is true?
That segment FL and segment LA are congruent.
Perfect. You did great. The question is, why? Number 5, that would be Peter.
What's the question?
How do we know that that's true?
Definition of midpoint.
Perfect. It's not great when you have to clap for yourself. That step, everybody should be getting that at this point. The next step I think is harder, so I'm going to ask for a volunteer. It's based on these two parallel lines. If these two lines are parallel, I need some angles inside the triangles. They're going to be congruent to each other. Peter?
Angle ALG and angle LFS.
Yes.
Smart. Can I clap for myself?
You can clap for yourself. Can you also tell us why? You're on a roll.
Alternate interior angles.
You were doing so well.
Oh, this is same side interior. Dang it. What? Oh, congruent?
Blake, help him out.
I have no idea.
Oh, I thought you were helping him.
I got it.
Same side in, wait, I already said
I got it.
You got it? All right.
Corresponding postulate.
Yeah, it's the corresponding angles postulate.
That's what I was saying.
So now, if we've got that, now I have enough to prove the two triangles congruent. I'll give you about 30 seconds and I'm going to call on somebody. Pardon?
May I ask the question one more time, please?
Yeah, what are we going to do next? How about this? I'm going to give you a hint. We're going to prove triangles congruent. And the question is, how? Stetson.
Triangle FLS equal, or is it congruent to triangle LAS?
Hang on a second, let me get caught up with you. FLS is congruent to triangle. What'd you call the other one?
LAG.
LAG. Okay, I like it. Why?
Oh, because of all the reasons of
So your choices are side, 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 side angle, side, angle, side, angle.
Okay,
All right,
let's see.
shh.
Oh, side angle side.
Yes, this is side angle side.
Let's go.
Good.
You can see the side, they're the same sides of the same angles.
Okay.
Oh, I just looked at the notes.
That's cool, smart guy.
Yeah, that's yesterday's notes for those of you who weren't there.
Okay.
Smart.
So, once I know those two triangles are congruent, then any matching pieces. And does AG match LS?
Yes.
Yes. So segment AG is congruent to segment LS by the definition of congruent triangles. Is anyone not ready to go on to the next one?
So S is for side, A is
All right. So we'll write down our given. There are two different things that we could do next. I will accept either one of them, but I'm going to call on somebody because you should know one of them at least. You probably should know both of them at this point. Hang on, I'm going to randomly call on somebody. That's possible I could call on someone that I already called on. Let's see, 13. So I'll ask you a question. You weren't here yesterday, we did, but this is on some of the stuff that was from the homework over the weekend. If we bisect an angle, so we're bisecting angle ARO. What do we know if we bisect that angle? Everyone else be quiet, please. Don't listen to him and don't say anything or don't look at him for answers.
Angle ARW is congruent to angle RWO.
Oh, RWO is down here.
Oh, angle.
Don't look around. You've got it.
Um,
The middle letter needs to be R.
oh, angle ORA.
OR. ORW. There we go. Angle ARW is congruent to angle ORW by the definition of an angle bisector. We have used up everything in the given. So now we have got to get something out of the diagram. Chris, what can we get out of the diagram on this? You are desk 18, right? What is it that you can see in the diagram that's always true? where these two triangles are stuck together. Yes. Can you really impress me and say why? Perfect. It's reflexive property. Segment RW is congruent to segment RW by the reflexive property. Once I have three pairs of things congruent, that's almost always enough to prove the triangle's congruent. Peter, eyes front, please. So if I look at just one triangle, I've got two sides that are marked and only one angle. So I always start with the sides. I can name the first triangle any way I want. I'm going to call it ARW. So, Angel, what triangle does that match up with? If I go from A to R to W, what do I need to do on the other side? So that all the pieces match up. What does A match up with in this triangle over here? O. And then R matches with R. And W, exactly right. Gerson, you weren't here yesterday. Let's see. 17. Carter, what reason can I give for why these two triangles are congruent? Say it again. Yeah, side angle side. I've got two sides and the angle that's in between them, so that's side angle side. I'm not done yet because I haven't gotten to what I want to prove. But if I know the triangles are congruent, I know their corresponding parts are congruent. That is the definition of congruent triangles. All right, let me give you your worksheet.